we are talking about rational and irrational numbers again and how we're going to classify them. So we know there are several different ways that we classify the numbers based on their decimal, based on if they're a perfect square or an imperfect square, and we talked about those things yesterday. So I just want you to recall your work on irrational and rational numbers, and we're going to review that now. I'm going to ask you some questions. So on your whiteboard, write a number, each of you individually. I want you to write a number with a terminating decimal. We're just going to review some of that vocabulary from our lesson. Write a number with a terminating decimal. And then I want you to hold it up. Don't let your neighbors see it. A terminating decimal. All right. 2.3. Good. 3.46. Good. 0.123. Good. Good. 5.78. Awesome. So lots of different numbers, but all terminating decimals. Okay. Can you show me a number with a non-terminating decimal on your board, please? A non-terminating decimal. And you can hold it up. Good. Mitchell used the repeating sign. That's awesome. And all of you have the dot, dot, dot. Ooh, is that pi? Are you using pi? Good. Awesome. Okay, so you can erase your boards. Now, I know Mitchell already did this. Some of you did not. Show me a number with a repeating decimal. A repeating decimal. Give me an example. How would you write a decimal that's repeating? Okay. Some of us have forgotten our repeating symbol. If you've forgotten, look to your shoulder partner. Make sure their number is a repeating decimal. Remember the little symbol goes above the number and tells me that it's a repeating decimal? Good. Awesome. Now, we are going to classify a number. So I want you to look up here. This is what your poster paper will look like in a minute. I'm going to have you with a pencil or a marker. Actually, we'll just use pencils first. You're going to put rational numbers and irrational numbers in the top right section of your paper. And then on the left section, you're going to have these classifications. A terminating decimal, a non-terminating repeating decimal, and then a non-terminating non-repeating decimal. So you're going to have to pay close attention to those vocabulary words that we've been talking about. Let's see here. If I had 0.123 repeating, we are going to classify this based on its characteristics. So remind me what the little bar over the digits mean? Repeating. Good. And then that's the same thing as 0.123, 123, 123, dot, dot, dot. Right? That's our example. Okay. So in which row of the table does that number go? Raise your hand if you can tell. Which row? Mitchell. The second one. Why does it belong in the second row?
Because it doesn't terminate.
Because it does not terminate. And remind me, somebody raise your hand and tell me what terminate means. Noah?
Stop.
To stop. So since it has that repeating bar, it does not stop, so you're correct. It's non-terminating, and yes, it's repeating. Good job. So, show me on your whiteboard, using the letter R or I, is this number rational or irrational? Is this number rational or irrational? Okay, I want R's to put your boards down and I's to leave your boards up. I need an I to raise their hand and tell me why it's irrational. Tyler? Because it's non-terminating. Okay, anybody else have a different justification for why it is irrational? Okay, put your words down. Ours, raise your boards. I need somebody to raise your hand and tell me why it's rational. Anybody know? Anybody have a justification for why it's rational? It's okay. Tell me what you're thinking. What are you thinking, Jordan? Why do you think it's rational? You don't know? Did you just guess? Kinda? Okay. I guess you don't have your interactive notebooks out right now, so you don't have your foldable. So there are different rationales for why this could be rational or irrational. Let's see here. We're going to talk about that a little bit more in a minute. But right now, we're going to classify the numbers that we have in front of us. So you should have been given these two pages. And both of them have rational and irrational numbers on them. There are a few blank squares that you are going to come up with your own numbers. So based on what you know on rational and irrational numbers, you're going to come up with your own numbers. So when you cut these out, you're going to give those to the group directly behind you, and then the group behind will bring them up front, and then behind, and then behind, okay? So going ahead and now discuss with your partner and write down, I think you have 4 blank squares, the numbers that you want to put in those squares. If you have questions, I'll be walking around. You get to choose whatever number you want, and then your partners are going to classify them. Okay, once you have your numbers written down, you should have them written down at this point. Okay, a couple more minutes. She asked if she could use her interactive notebook. Absolutely, you can use your resources. You absolutely can use your interactive notebook. That's what it's there for. That's why we put that foldable in it yesterday. So you should should be cutting out your numbers now. And make sure each page has 9 squares, so you should have 9 individual squares when you cut those out. I'm going to put a trash can in between each row so it's easy for you to put your trash away. Okay, once you have your squares cut out, I need one partner to take his or her pencil, or if you want to use your marker, you may. And I want you to label your poster, your own poster, with this, okay? So you're just going to have rational numbers maybe in the center, irrational numbers over here to the top right. And then down the left-hand side, terminating decimal, non-terminating repeating, and non-terminating non-repeating. I think the red marker might actually show everybody about that. If it doesn't, I have some black markers. Sure. Yeah, if you need to. You're welcome to. If you want to write it with a pencil, then I can send around a black Sharpie to fold it in. So write it down and you can go. The red marker, Ryan is writing with the red marker. It's showing up really well, actually. So if you want to use the red marker on the blue paper. Yes. I'll get you one. Does anybody else need a ruler? You don't have to draw the lines. You do not have to draw the lines. All you're drawing or writing are these words. Okay? You don't have to draw the lines. Yes. Once you've done that, once you've got your squares cut out, and you have your paper labeled, give me your attention. These are looking good. that it all fits. Okay, you should only be conversing with your partner right now. Okay. I'll give you time later to go back over it if you've written in pencil, but I want to go on ahead and give you instructions. So if you'll stop writing, put your pencils down. Now, if you will recall, okay, we talked about yesterday how non-terminating decimals, the ones that go on, are typically considered irrational numbers, right? The difference between those non-terminating decimals that are classified as irrational numbers and the non-terminating decimals that will be considered rational numbers is this. When you have a number, okay, we're going to review this. When you have a number, for instance, 0.123 repeating, a non-terminating repeating decimal is actually considered rational, okay? So a non-terminating repeating decimal is rational. If it was non-terminating but it didn't repeat, it was just some random numbers, 0.2367, ... that would be considered an irrational number. So just to clarify that from yesterday, now I'm going to give you directions on how to construct your diagram, and I can go back to this slide here in just a minute. Does anybody still need this up here? Okay, I'll flip back to this in just a second, but right now I want you to follow along with me in the directions of what we'll be doing. So, here's some instructions for working together. All students in your partner pair will be able to give reasons for every placement of a number. Don't glue things in place or draw on lines of the poster yet, as you might change your mind later. That's why we didn't draw the lines. So, what you're going to do is classify them to whether or not they are rational or irrational. You're going to take turns to choose a number card. So for instance, if I was Adam and I picked up 0.23, just plain old 0.23, then I'm going to decide where my number card fits based on my classifications. Does it fit in just one place, or does it fit in more than one place? I'm going to give a reason to my partner for why. So, for instance, I might go over here to Brian. Okay, I think this is a rational number. It is a terminating decimal. Do you agree? Awesome. Let's put this one here. Okay, so I would justify my answer to my partner, tell them why, put it in that spot, and then you're not going to paste it down until the end. So be careful, don't cough on your paper, and then you'll blow your numbers over. You'll have to start all over. So if you agree with your partner's reasoning, explain it in your own words. If you disagree with your partner's decision, explain why, and then together figure out where to put the card. So that's kind of what we're doing, and yes, you can use your interactive notebook, yes, you can use your foldable. When you've reached an agreement, write the reasons for your decision on the number card. So somewhere on this, you're going to say, okay, the decimal doesn't repeat, it's non-terminating, or terminating, you would say those things on your number card, and then if the number card fits in just one place on the poster, we're going ahead and paste it on the folder, or poster, and then if not, lay it to the side and we'll discuss them as a group later, okay? Do I have any questions? Make sure that you're using your math words and you're justifying your answer to your partner, and make sure you don't paste them down until you're absolutely sure that's where they go. Awesome. And I will put this slide back up for you. Okay, you may begin. Remember to use your inside voice. Yes, so let me have your number cards that you created. Can you pick them out, Cody? And then let me have the number cards you created. talking to your neighbor about why and where these numbers go. So choose a card. Pass them to the group behind you. There you go. Here are ones that y'all created. What are these? Where are the ones that you created? Awesome. Thank you. And you have some now? Okay, perfect. If you have a question, raise your hand. Okay, so let's practice. Choose a number. Jonathan? Alright, so what do you think about this? Point 1, 2, 3, round into 3 decimal places. What do you think? Is it terminating? No. Is it terminating if it's rounded to 3 decimal places? What do you think, Jonathan? Non-terminating, okay. So do you think it's non-terminating repeating or non-terminating non-repeating? Awesome. Do you agree with him? Why do you agree? Okay, good. That's how you'll do it. All right. Does anyone over here still have trash they need to throw away? Yes, ma'am. You're doing them all? Yes. Danielle just had a great question. She asked if you were just doing the partner created numbers right now. The answer is no. You are going to go on ahead and work your way through all of these numbers and justify your answers. Okay, since it's a non-perfect square, would that be considered a rational or irrational? Irrational. This is a non-perfect square. So it wouldn't be terminating decimal, would it? Because you know, all the ones that we see, they ended up having a lot of numbers in the decimal. So it's either going to be a non-terminating decimal or a non-terminating non-decimal. So you can choose. And then we'll talk about those. Okay. This is a tricky one. Remember we talked about how slice numbers all the way to the end of the calculator and it just stops there. Do you think? Okay, so is it a terminating decimal or a non-terminating repeating? Does that repeat? What repeats in it? Okay, let's talk about this. Okay, we've got a good example here. So all of you have the one that says calculator display, correct? Okay, so I want you to get that one and look at it. Remember we talked about yesterday when we have a calculator display, you might have numbers that fill up the calculator display. Does that necessarily mean that that's it? That that's the end of the number?
No.
No. So that being said, is this a terminating decimal, do you think, or non-terminating? It's probably non-terminating. There are probably more numbers behind it, so consider it to be one of the ... ones. And then we've got to establish, since we know it's one of these two lower ones, non-terminating, is it repeating or is it not repeating? Well, the numbers are 3.14159265. Is that going to be non-repeating or repeating? Non-repeating. None of those numbers repeat to our knowledge. So we would put that under rational or irrational? Irrational. Okay? So there's one for you to check. Make sure you have it in the correct spot. If you didn't have that one, then you just got a freebie. Here in about 5 minutes, I'm going to call on a couple of groups to choose one and tell me where they put it and why.
I think we're gonna restart it.
Yes. If it repeats, is it terminating? That's the question you need to ask yourself. No, it's not terminating if it's repeating. So you've got to decide if it's a repeating or a non-repeating. You know it's not terminating because it is repeating, right? Does pi terminate or does it keep going forever and ever? It keeps going forever and ever and ever. So where would it go? We know it's non-terminating. So does it repeat or does it not repeat? It doesn't repeat. Pi is one of those numbers, 3.1415. It's actually one of your other parts. So we'll talk about pi again, but it's actually, you're right, non-repeating.
We know it's rational.